This is about types of chemical reaction. Types of chemical reaction. There are different types of chemical reaction. One is the combination reaction. Combination reaction. So in combination reaction, two or more reactant forms one compound, only one compound. So that is a combination reaction when two or more reactant give only one product, that is known as combination reaction. It's known as combination reaction. For example, calcium oxide, which is also known as quicklime, plus water that is liquid form. When calcium oxide reacts with water, it gives calcium hydroxide, CaOH whole twice. So calcium hydroxide we are getting. So this is a combination reaction because here calcium oxide and water both combine together to give calcium hydroxide, and this calcium hydroxide is known as slacked lime. Slacked lime, and this is used to whitewash walls of the room or the building. Okay, so this is combination reaction. Other examples can be like carbon plus oxygen. So that gives either carbon dioxide or carbon monoxide. So that depends upon the quantity of oxygen present. If the oxygen present in sufficient quantity, then the product will be carbon dioxide. When the oxygen is insufficient, then the product will be carbon monoxide. Okay, so when carbon reacts with oxygen, it gives two types of product. One is carbon dioxide and other carbon monoxide. So that depends upon the presence of oxygen. Now one example more I can give you, the reaction of hydrogen with oxygen. We get water. Okay, a reaction of hydrogen and oxygen, we get water. So this is also a combination reaction because hydrogen and oxygen has combined together to give only one product, that is water. Yes. So now look at the reaction of this combination reaction. Okay, um, maybe endothermic or exothermic. Calcium oxide when react with water to give calcium hydroxide. So this is a highly exothermic reaction. This is highly exothermic reaction. This is highly exothermic reaction. So whenever any hydrocarbon burns in air, or you can say in oxygen, two things are obtained. One is carbon dioxide plus water and heat, a lot of heat. So this is a exothermic reaction. This is also exothermic reaction. One more exothermic reaction is the this is respiration, in which the glucose break down into carbon dioxide and water. The breaking of glucose during respiration into water and carbon dioxide and a lot of energy. So this is also an exothermic reaction. And the decomposition of vegetable matter into compost. Decomposition of vegetable matter into compost is also an example of exothermic reaction. Next comes decomposition reaction. That is decomposition reaction. So this is just opposite to composition reaction. In this, single reactant break up into two or more product. Okay, decomposition is just opposite to composition. In this reaction, a single reactant breaks up into two or more reactant. For example, if ferrous sulfate FeSO4 is heated, it is in solid form. It is usually, green color. It is ferrous sulfate is green in color. So when ferrous sulfate is heated, the product obtained is ferric oxide, sulfur dioxide, and sulfur trioxide. Okay, two gases we get. One is sulfur dioxide, other is sulfur trioxide, and ferric oxide. This is in solid form, and sulfur dioxide and sulfur trioxide in the gaseous form. Okay, here this is a decomposition reaction because a single compound, ferrous sulfate, so that breaks up into three things, three reactants you can say. One is the ferric oxide, other is sulfur dioxide, and the third one is ferric sulfur trioxide. Yes, one important thing here also, this ferrous sulfate has a green color and it contains 7H2O as water of crystallization. Water of crystallization, it contains 7H2O. So when ferrous sulfate is heated, its color changes into white gradually. Okay, it white here unless this and when it is left to cool down, so again it absorbs water of 7 molecules of water crystallization, and again it becomes green in color. So the decomposition reaction, one more I can give an example is this is calcium carbonate, decomposition of calcium carbonate. Calcium carbonate when heated, when it is heated, it gives calcium oxide and carbon dioxide. Okay, it gives calcium oxide and carbon dioxide. Calcium oxide is a quicklime, and this carbon dioxide is a gas. Calcium carbonate is also known as limestone. It's also known as limestone. So these two examples, the heating of ferrous sulfate and this calcium carbonate. So they are the decomposition reaction because they decompose into two or more product. Now, one more example is the heating of lead nitrate, PbNO3 whole twice. Lead nitrate, when it is heated, lead nitrate is heated. The product obtained is lead oxide. Nitrogen dioxide and oxygen. Here also the two gases are liberated. When lead nitrate is heated, so the product obtained is lead oxide. Lead oxide it is, and nitrogen dioxide and and this oxygen. So these three are the examples of decomposition reaction. Now some more examples. When silver chloride is left in the sun, silver chloride when left in the sun, it decomposes into silver and chlorine gas. Yes, AgCl3 when left, this is solid form. When it is left in the sunlight, it gets energy from the sunlight and break up into silver and this this chlorine. So okay, in the same way, is if a lead, okay, this lead bromide, when when exposed to sunlight, it breaks up into lead and it breaks up into silver bromide. Okay, when silver bromide is left in the sunlight, so it breaks up into silver and this bromine gas. Yes, and these two now like the above two reactions, that means the two reactions like silver, the decomposition of silver chloride or decomposition of silver bromide. So these two reactions are used, okay, in the photography, in the black and white photography. This is used in black and white photography. These two reactions. Which one? Silver chloride and silver bromide. When they decompose into silver and chlorine gas and silver into this bromine gas. So this is all about this decomposition reaction. Next is the displacement reaction. Displacement. Okay, in this displacement reaction, a more reactive metal displaces a less reactive metal from its aqueous solution. Okay, a more reactive metal, displaces a less reactive metal from its aqueous solution. For example, ferrous iron is more reactive than copper. So when, okay, copper sulfate, so when in the solution of copper sulfate, when iron is dropped, okay, so the reaction starts, okay, the reaction starts now here. So we get now iron sulfate and copper. So copper is displaced in this reaction. So okay, in the same way, you can say, zinc is more reactive than copper sulfate. So, zinc and copper sulfate in the aqueous form, means water mixed form, reactive gives zinc sulfate and copper. And same way, the lead is also more reactive than copper. Then lead plus copper sulfate. Okay, we get now lead sulfate. Okay, we get lead sulfate and we get copper now. Yes, so this is the displacement reaction in which a more reactive metal displaces a less reactive metal from its aqueous solution. Is correct? Now, then comes the double decomposition reaction. Okay, in this type of reaction, the ions are exchanged. Okay, the ions are exchanged. Okay, among themselves. For example, look here, sodium sulfate in the aqueous form, means water mixed form, sodium sulfate. This is the second one is barium chloride, BaCl2. When they react together, we get barium sulfate. We get barium chloride. Sodium sulfate plus barium chloride, we get barium sulfate and sodium chloride. As the ions are exchanged, so barium, sodium sulfate, and when barium chloride, these two can react together in the aqueous form, then we get sodium chloride and barium sulfate. As the barium sulfate is insoluble in water, therefore it forms precipitate. It's called PPT in the short form, PPT. And we get now this is a precipitation reaction. This is also known as precipitation reaction because we get a precipitate in this double decomposition reaction. The next is oxidation and reduction reaction. In this case, in this case, either oxygen is added or oxygen is removed from a reaction. So that that depends upon the type of reaction. So when the oxygen is added to any reactant, then it is known as oxidation reaction. For example, suppose copper plus oxygen, so that gives copper oxide. So this is so these things have been oxidized. Okay. And secondly, when copper oxide plus hydrogen, copper oxide plus hydrogen, and then we get copper plus water. Here this hydrogen is a reducing agent, so it has reduced copper oxide into copper, and the oxygen from this copper oxide, okay, this oxygen from this copper oxide now, okay, forms the product. It's okay, it's correct. In the same way, now that this copper oxide plus hydrogen, so this gives copper plus water, it gives now here, so copper is released in this case. So that is the reduction, because oxygen has been removed from copper oxide and it has reduced into copper in the copper Cu. Therefore, this is known as reduction reaction. So these are all the types of reactions I have discussed now. I hope it will be useful to you. Thank you very much.